Welcome to Tips and Tricks video. In this video, we will demonstrate how to use image to create non-uniform material. Properties of such materials are functions of spatial coordinates. An example of such material is shown on this image. Here, the color scale represents relative variation of the material property. For demonstration purposes, we will use very simple problem of acoustic scattering. Pressure acoustic physics is used to solve this problem. Incident pressure field is defined in the background pressure field node. Here we have plane wave traveling in the x direction from the left to right. We use perfectly matched boundary to model open boundaries to allow pressure wave leave computation domain without back reflection. We have two materials. Material 1 is acoustic media material defined by density ρ1 and speed of sound c1. We have material 2, which is scattering material with different properties, density ρ2 and speed of sound c2. Let us solve the problem. To do that, you go to the study and click Compute. It takes several seconds to get solution. After solution is done, we see the total pressure due to scattering from the uniform object. Now we want to define non-uniform material using the image file. To do that, we right-click Component Geometry Global Definition, Functions, and Image. Then click Browse, and we find the file to import the image into the model. We click Plot, and now we have image which can be used to define non-uniform material. Image somewhat unusual, but it's okay for our demonstration purposes. Note that the scale changes from 0 to 1. We can assume that the scale 0 corresponds to one material, scale 1 corresponds to material number 2, and everything between is the mixture of two materials. Now, we are ready to define heterogeneous material. To do that, I will add variables node under component. I right-click definitions and add variables node. Here I want to define volume fraction of the material 1, speed of sound of the mixture, and density of the mixture. To define those variables, I read those variables from the text file. And here I have theta, which is a variable for the volume fraction of material 1, is defined as im1, which is the name of the image function. Arguments are x and y, which are spatial coordinates. And then volume fraction of the second material is just 1 minus theta. Now we have volume fraction for the first material, for the second material, and I can define speed of sound of the mixture. Speed of sound of the mixture is speed of sound of material 1 times volume fraction of the material time of material 1 plus speed of sound of material 2 times the volume fraction of the material 2. And similarly, density of the mixture is defined as density of the material 1 times volume fraction of the material 1 plus density of material 2 times volume fraction of the material 2. We can also visualize material properties of our domain to ensure that everything is defined as expected. To do that, I add 2D plot group, then add surface subnode, and go to the replace expression to plot density of the material. I go to the material properties, find variable for the density, and then I change color scale to gray, and what we see, we did retrieve original image which was used to define properties of heterogeneous domain. That's all for now. We have demonstrated how to use image function to define material with properties depending on the x and y coordinates. Hope this was helpful, and thank you.